Hello friends, welcome back to our channel. So today we'll see a few more problems to find the valid conclusion using inference rules. So in our previous session we are discussing about the inference theory. So where we have seen some case studies or some premises and we have seen some conclusion, so that we have to prove that that conclusion is a valid conclusion by deriving that conclusion from the given premises by using inference rules. So in our previous sessions, we have seen that both the inference rules as well as the laws of logic. So with the help of both, we have to derive the conclusion. So if you derive the conclusion with respect to the premises, you can say that the conclusion is a valid conclusion for that particular argument. So in our previous session, we have seen three kinds of problems, where first one will be giving some case study. From that case study, we have to identify the propositions, and after identifying the propositions, we have to formulate the propositional formula, and then we have to find out the premises and the conclusion, and finally we have to conclude, or we have to derive the conclusion from the premises. That's the first kind. Second kind, directly they will be giving some propositions. From that propositions we have to form the premises and conclusion. And the third kind, directly they will be giving the premises and conclusion, so that we have to derive, or we have to check whether the given conclusion is a valid conclusion or not. And among all the three, the third one is somewhat difficult. So if you are having some case study, you might be knowing that the conclusion is a valid or not. So in the third case, directly they were giving directly the premises and the conclusion. So we don't know the statement, so we don't know the argument, so we can't say the conclusion is a valid or not. So but we just try to prove that conclusion is a valid, right? So in today's session, we'll see a few more examples which follows rule CP and rule P and rule T. So mainly three rules we have seen. So among that, in our previous session examples, we have seen both rule P and rule T. Rule P means at any point of time we can introduce the existing premises, okay, into the derivation. And rule T, so based upon the above premises, we have to formulate a new formula. We have to introduce a new formula. That is a rule T. And the third one is a rule CP, which is a conditional proof. If your conclusion is having some implies, then consider the LHS as the first premises, as one of the premises, and along with that, by considering all other premises, we have to derive the RHS. So consider LHS. With the help of LHS and the premises, we have to derive the RHS of the conclusion. So then we can say the conclusion is a valid. This session will mainly concentrate on the conditional proofs, that means the rule CP. So let's start the session. So valid conclusion, we have to check this valid conclusion using inference rules. So not only the inference rules, we can also use the laws of logic, right? So we'll see one by one. Now let us see the example. So this is example 1. So in this example 1, there are three premises. So these are the premises, and this is a conclusion. So with the help of these premises, we have to derive this conclusion by using the inference rules. So here there are no arguments given, directly the premises have been given. Now let us start here. So the first one is a premises number, the formula number, and introduce the first one, right? So P and Q. So it is not mandatory that always we have to introduce the first premise. So you can also consider negation R as a first premise. So let us take this one, negation R, which is rule P, because this is already existing premise, so we are using the same premise in the derivation. And the second premise and second formula, I'm introducing this one. P and Q implies R. So which is again rule P. So we have not derived any new formula, just we are introducing the existing premise. And you can observe here from 1 and 2, we can derive the third formula, so which is negation of P and Q. So this is the rule T. So how we got this one? By using modest tolerance rule. So modest tolerance, you can see P implies Q and the next negation Q, so which will conclude it as a negation P. So that is a modest tolerance rule. So here also the same thing, negation R, P and Q implies negation implies R. So obviously consider this one as a single term, so it will be negation P, so negation of P and Q. Now you can apply, so the third one, go with the fourth. So apply De Morgan's law. So you can apply the De Morgan's law. So negation P or negation Q. So which is again rule T. So De Morgan's law. So laws of logic. De Morgan's law means negation of P and Q that gives negation P or negation Q. So the same thing we have applied here. Okay. Now, so what's the thing? Here we need to get negation Q. So here P is there. Let us convert this into implies. So consider 5 with the fifth formula. So if you consider, so we know that implies, formula of implies, P implies Q, this can be written as negation P or Q. Similarly, here we can write it as P or negation Q. So if it is in the format of P implies negation Q, that implies negation P or negation Q. So the same thing. So here also we are using rule T, applying implies rule. Applying implies rule. Now you can introduce a third one, right? So here I will introduce 6 with the sixth formula P, and which is rule P, because this P is already existing premise. So we are just introducing that one. Now you can apply 5, 6 with 7th formula. So you will get a negation Q, so which is a rule T, which is a modest ponens rule. So previously modest tolerance, and here it is a modest ponens rule, which is P implies Q and P, which gives the conclusion as Q. Similarly, P implies negation Q, P, which gives a negation Q. So you can observe the conclusion is negation Q. So we got that conclusion. So this is a conclusion. So we have started with the premises and we are slowly deriving towards the conclusion, and we have succeeded. So that implies given premises and given conclusion is a valid conclusion. Hope you understood. So in this example, we have seen both rule P and rule T. So there is no question of rule CP because the conclusion doesn't have any conditionals. So one major thing we have to remember is, if your conclusion is having the conditional, then we have to apply the rule CP. So we have to consider the LHS as a assumed premises, and along with the given premises, we have to derive the RHS. So if it happens, then we can say it as a valid conclusions, right? So this is one example which implies the rule P and rule T. We'll see the second example with conditional proofs. See here the second example. So directly premises has given 3 premises: P implies, Q implies yes, negation R or P and Q. 3 premises, and the conclusion is R implies yes. So here we got the condition in conclusion. So in such case, we have to consider conclusion R implies yes. So this will be LHS and this will be RHS. So the first point we have to consider is consider LHS of conclusion as assumed premise. Assumed premise. So we have to consider R as also the premise, right? So now, what are the premises? What are the premises? First we have to consider this RHS, R. So which is a assumed premise. So this also we have to consider. Next, P implies, Q implies yes, negation R or P, Q. Okay, now we got a 4 premises. So previously there are only 3, but here in the conclusion there is a condition, right? R implies yes. In such problems, we have to consider the LHS of the conclusion as one premise. So with the help of all these premises, we have to conclude. Now the conclusion will be RHS, that is yes. So derive RHS of conclusion from LHS and all premises. So we have to consider LHS as one premise and also given premises, and we have to derive the RHS so that we can say the conclusion is a valid. Now let us start with this one, right? So I am introducing the first formula, that the first premise, first formula. So I'll take R, right? So this is a rule P, because which is an assumed premise. So we have considered that LHS as one premise, right? So that will be the assumed. So we have not derived anything. So just we are using the existing premises. Next, second one and second formula. So we can introduce the third one, negation R or P. So which is again rule P. So we have not derived any new formula. We are just using the existing one. So we can combine 1, 2. So we can consider the second one only. Third formula, derive the third formula. So we can convert this into implies. So which becomes R implies P. So by using implies formula, reverse implies, right? So if it is implies, then we can write equivalent as a negation R or P. So the same thing we have written here, right? So again, this will be rule T. So we have derived, okay, we have derived that one, or simply using implies. So this is with the help of implies, which is not an existing premise, right? So now with the help of 1 and 3, formulas 1 and 3, we can obtain the fourth one. So R implies P, which becomes P, which is a rule T. How it becomes P? With the help of modus ponens rule. Modus ponens. Modus ponens means if P implies Q and Q, then the modus ponens is P. So the same thing. R implies P and R, which gives the result as a P. Now we are having P, and here also we are having some P implies. So automatically we can include the fifth premise, the fifth formula. P implies, Q implies yes. So which is again rule P, because the same premise we are using, right? So we are not deriving any new thing. So just the same premise we are using here. Now you can observe 4 and 5. So you can observe. So you can write it 1, 3, 5 or 4 and 5. Sixth formula. So which is again in the modus ponens. P implies Q or S. So Q implies yes will be the result. And here it is rule T, and with reference to this modus, again ponens rule, modus ponens. Because of modus ponens, we got a Q implies yes. Now we are also having one more Q, so we can introduce that one. So seventh one, with the seventh formula, Q and it is a rule P because we have not derived this one, just we are using the existing one. So and you can observe here 1, 3, 5 and 7, we can derive the eighth one. So again it is a modus ponens. Q implies yes and Q, it becomes yes, and it will be rule T again with respect to the modus ponens, right? You can observe here what is the RHS of the conclusion? Yes. So this is the RHS. So we have derived the RHS by taking LHS as the assumed premise. So with the help of the LHS of conclusion and the existing premises, we are deriving the RHS of the conclusion. So we have taken R as an assumed premise, and with the help of the remaining premises, we are start deriving, and we finally got the S, which is a RHS. So that implies this is a RHS, and we can say it as a conclusion is valid conclusion. So if this happens, we can say it is a valid conclusion. So hope you got this. So this is nothing but rule CP. So you can write it here, rule CP, rule CP, right? So finally we can write it as a R implies yes, R implies yes, and rule CP. So this is an example for rule CP, that is a conditional proof. And once again I am repeating, so we have to use this rule CP only in such cases where the conclusion is having some conditional part, where the conclusion is having some conditional part. So in such cases only we have to use this rule CP, right? So we'll see one more example on rule CP and we'll close. So let us take the third example. So here also these are the three premises given. These are the three premises given. And from these three premises, we have to conclude P conditional S. So whenever we got the conditional in the conclusion, what we have to do? So we have to write down the conclusion first. P implies yes, and this will be the LHS, and this will be the RHS. Now, what we have to do? So these are the premises. What are the premises? The first premises will be LHS of conclusion. So which is P, we can write it as assumed premises. Assumed premises. So assumed premise, and write down all the remaining negation P or Q, negation Q or R. R implies yes. So with the help of all these things, what we have to conclude? So conclusion will be RHS of conclusion, so which is yes, right? So this is nothing but rule CP. So with respect to the rule CP, so if the conclusion is having the implies, so we have to consider the LHS as a assumed premise, and we have to derive the RHS. Let us start this one. So the first premise, giving the first formula, so I'll take P, which is a LHS. So previously we don't have P as a premise, right? So here P is a LHS, right? So we can write it as rule P, and this is a assumed premise, right? Now take the second formula, second premise and second formula, which is negation P or Q, negation P or Q, which is again a rule P, because we have not derived anything, so we are just making use of the existing premise. Now you can change the second one, so that we'll be getting the third formula. It is P implies Q, so which is again rule T. So we can write it as rule T, or simply we can write it as a implies. We are just changing that formula. So negation P or Q is changed to P or Q. P implies Q. Now you can see here, so 1, 3 would give the 4. P implies Q, which is always a Q. So this is a rule T with respect to modus ponens. Modus ponens rule. Modus ponens rule. Okay. And now I'll include the second one. So fifth one is the fifth formula, negation Q or R. So which is again rule P, because we are just using the existing premise. Again now I'm changing the 5 so that I'll be getting the sixth formula, which is a Q implies R. So again, which is rule T. So it is a implies formula. So I have converted this one into implies. Now you can see 1, 3, 5, which gives the seventh formula. So which is a Q, and again it is a real rule T. So this one, see 1, 3 and 5. So what happens here? So it gives, so with respect to modus ponens. So we got a Q. Sorry, Q implies R, so the result will be R, not a Q. Now go with the eighth formula, include R implies yes. R implies yes, which is a rule P, because R implies yes is already here, so we are just using that R implies yes. And now you can use 1, 3, 5, 8, which gives a ninth formula, which is again yes. It is a rule T. Again here we can see modus ponens only. Okay. And now you can observe this one, yes, which is a RHS. So that implies it is a conclusion, and it is rule CP, conditional proof. Okay, so hope you understood this one. So in this session we have seen some 3 examples. Okay, so 2 are related to the rule CP and 1 is related to rule P and rule T. And the same thing, you did not use these things. You can directly, then there is one more approach you can observe. So first this can be taken and this can be written as a P implies Q, and this can be implemented as a Q implies R, and both by using both it is like a hypothetical syllogism, so which gives the result as P implies R. And again you can introduce the next one, R in conditional yes. Again by using hypothetical syllogism, you will getting the result as P implies conditional yes, which is a conclusion. So that means one problem can be it can have many solutions. Okay, so anyway we have to derive the conclusion. That's the main concept. So you can apply, you can consider any premise in the order, and finally we should get the conclusion, right? So we have to derive the conclusion. Yes. So let's stop here. Hope you understood everything. So if you are having any doubts or queries regarding this procedure, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts regarding rule P, rule T, rule CP, inference rules, everything. And once again I'm repeating, just remember all the inference rules and the laws of logic, so that it will be very easy to solve any kind of problems. Okay, just to practice the inference rules and the laws of logic. Yes. So, yeah. So if you enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.